Welcome to part 3 of the helmet. Let's take a look. Put a fillet across this edge. Anytime you have to get a fillet to blend into something that's already blended, you run the risk of that fillet failing. What I've done up here is I've created another vent. Should have named these features. You can see here how having names on these features would have been helpful. In any case, I have this series of vents that I want to create down through the top of the helmet. And so I trimmed out the entire top section. And then I created an extrude surface to act as the tangency control across the top of the model. From there, I created a boundary surface, and it looks like I should have used 4 separate features to create this, but I did it all in one, and I think I got away with it. It looks nice. It's kind of like a dragon scale sort of effect on the top of the helmet that would act as a stiffener for the helmet, or maybe it just helps your head get traction against the grass when you're down in the rough like that. Okay, so now I've knit this into the rest of the body, and I do a surface trim to cut some more holes. Okay, here's another hole, and I use a ruled surface this time. A ruled surface is an excellent tool. This is something that you really need to get comfortable with, because it can save you a lot of time, and it can give you kind of a surety in certain situations that you're creating the right surface, especially if you're involved in mold design. Now, if you're in mold design, you probably know this already, but if you're in product design, it's not a bad thing to know either. So let's take a look. Well, let's take a look at what the ruled surface does. There are several options for the ruled surface. You can make a ruled surface that's tangent to the reference surface. You can make one that's normal to the reference surface, so perpendicular. This one is, in fact, tapered, and you can set up a taper angle that's tapered to a vector, not tapered to the surface. So you have to then establish some sort of vector, and in this case, it's just the right plane. Perpendicular to the vector is another option, and a sweep. I'm not sure this is one I can describe, but the sweep is one that you'll use when you have a long edge and you want to have like a thickness surface that goes along that edge at a prescribed distance and a prescribed angle along a given edge. This is one you'll probably need to play with. The property of the ruled surface, and this is helpful to know, we've talked about the NURBS surfaces and the fact that they have U and V lines. So there's lines in 2 directions on a NURBS surface. Well, on a ruled surface, one of those directions is always going to be a straight line. That's the property of the ruled surface that you want to be able to count on. If you're creating surfaces with draft from a 3D edge that's not necessarily planar, the ruled surface is the way to go. Okay, from here we trim out that surface, and then we use a boundary surface to close it up. And see, here we've done something different again, just a different way to create this vent. Then we're going to have to come back later and put fillets on that to round it out. All right. Now let's see what this split line is probably up front. Yeah. So we're back to the front, creating some more surfaces. The surface extrude puts some gaps in here, which is nice. The holes in this are just the surface texture thing. These aren't actual holes. I mean, I didn't have to sketch these and extrude or trim or anything. Notice that the surface extrude put these faces on the center plane for me. didn't want those really, but I got them anyway. So I just used the delete face to get rid of them. And then I applied draft, a couple of draft features to draft out that area. And now I'm back to a ruled surface. Have to see what this is about. Oh yeah, now we're putting along the seal that you'd get for your visor in this area, and the ruled surface is an excellent tool for this. I mean, it was just built to do this kind of thing all day. The first ruled surface came off the surface perpendicular at a given distance, and then we did the same thing from the edge of the first ruled surface. And that just makes a mask seat very well. If you were to try to do that with a sweep, you'd be trying to control the rotation of the sweep the whole way, and it would just be, not a lot of fun. Let's say it that way. I get involved with putting fillets on everything. Fillets are really best left to the end. And if you don't have the discipline to do this, you're going to run into a lot of trouble. Because if you had started putting fillets way up here in the tree, then some of your features are going to be dependent on fillets. And fillets are very fleeting and fickle, you might say. So, you might have to replace a fillet or delete it and then recreate it, something like that. And if you do that way back in the tree, you're going to have a lot of busted parent-child relationships. From here, we add a split line, another surface extrude, and some fillets. Let's see what this was all about. Put some gills here in this area. That's very nice. And finish up with a surface loft, which is around the neck piece, just to give it a little thickness. And then finally, the mirror feature. That finishes out the model. Now, of course, you probably should also run a knit feature to knit these two halves together. And if you were going to finish this model, you'd have to find a way to give this an interior surface for the thickness of the material. That, I'm sure, would be a challenge, but given what you've done already to get this far, the rest of it should be easy. So thanks for watching. I hope you found this valuable, and we'll see you in the next video.